to escape. Flames race through the tunnel, engulfing everything in their path. Firemen are blasted with a wave of poisonous gases and temperatures that reach 1,000 degrees Celsius. 66 people are reported missing. It takes 53 hours to control the fire. When it's all over, 39 people are dead, and the Mont Blanc Inferno will go down as one of the deadliest tunnel fires in history. In Kuala Lumpur, safety officials know that accident and fire will be constant threats to the Smart. The critical question will be, how fast can they control them? From the start, safety has been a key focus of the Smart Tunnel's design. Every kilometer, teams have dug out ventilation shafts and escape routes leading to the city streets above. Every 250 meters, passages connect both road decks. Dozens of closed-circuit TV cameras monitor every inch of the roadways for the first signs of trouble. Waterproof safety lights had to be designed to withstand the force of raging floodwater. At the center of it all, a state-of-the-art control room. Smart's safety team has also been trained for a worst-case scenario. And on April 5th, 2007, that's exactly what happened. Inside the Smart Tunnel's top road deck, two cars have collided and flipped. In both, injured passengers. Flames start to engulf the vehicles. The control room spots the fire. The passengers are trapped. Rescue crews try to reach the scene, but smoke is filling the tunnel. An alarm notifies the control room that air quality is dropping fast. Fans in the ventilation shafts start to disperse the smoke. Medics finally reach the injured drivers. Firefighters start to douse the flames. The smoke levels appear to be dropping. The passengers are on their way to hospital. And soon the fire is out. Officials breathe a sigh of relief. They have staged this accident to test the Smart's safety team. There's no telling what would happen in a real emergency. But this test, at least, has been a success. The Smart's roadways will reduce congestion and traveling time into the city center. The tolls collected will help repay the $500 million cost of building the Smart. But unfortunately, the risk of a project overspend continues. Tunnelers still have 552 meters to go in the North Drive. Their TBM is chewing the earth 20 meters below a popular commuting route. And Smart's engineers could soon have a potential catastrophe on their hands. The TBM will have to drill extremely close to these, the pylons of Malaysia's national grid. If one of these towers topples, it could shut down power to much of the city. Ensuring the safety of the pylons falls to Senior Geotechnical Engineer S. Satkunasilan.
The three pylons that are in close proximity to the TBM alignment form part of the national grid, and that makes it super sensitive.
As the TBM approaches, Satkunasilan's team reinforces each pylon and carefully monitors it for the slightest evidence of movement. Meanwhile, the giant drill is grinding its way closer and closer. In the TBM's control room, the driver starts to coax it as they near the pylons. he keeps his eye on the slurry pressure. Any drop in the gauge could be a sign that the ground is collapsing under the pylons. It takes 4 days of carefully waiting and watching. Finally, the TBM is past the danger zone. This risk to the national grid is over for now. The North TBM continues to grind its way forward. Now, tunnelers have to commute 5 kilometers into the tunnel to reach the giant drill. The further in they go, the hotter it gets. Giant fans pump cool air into ventilation ducts that stretch all the way to the TBM. The tunnel is like a giant artery, feeding the men and machines inside with vital supplies, power, and a steady stream of concrete segments for the tunnel lining. But when it comes to boring, the most crucial material of all is bentonite slurry. The thick gray liquid plays 3 critical roles. It keeps pressure on the rock face to avert sinkholes, provides a protective coating to the giant drill as it grinds forward, and carries the mined waste material back out of the tunnel. Above ground, an enormous slurry plant is working around the clock. Inside, huge machines process and clean the slurry coming from the TBM. The mined rock and soil is separated and sent on to other construction sites. The clean recycled slurry is then piped back underground to the TBM to start its journey all over again. Giant pumps keep the slurry moving round the clock.
This is the P2 slurry pump. It's on the machine. You can see the stones bouncing around in the pipe. This is the heart of the machine other than the cutter head.
The pipes and pumps move enough slurry in and out of the tunnel to fill up more than 600 Olympic-sized swimming pools a month. Any break in the supply chain and the entire project can come to an expensive and messy standstill. March 2007. The TBM and its crew is just days away from their prize, breakthrough point at the tunnel's northern end.
19 more rings to go!
But what happens next comes without warning. A huge drop in pressure on the slurry pipe feeding the TBM. Suddenly, hundreds of liters of thick slurry are flooding the tunnel. The slurry shorts a key electric cable. The TBM grinds to a halt. Now, the tunnelers are 5 kilometers inside the North Drive in almost pitch darkness. They need to find the problem and fix it fast. The only choice is to wade through the thick liquid and search for the leak by hand. Attempts to repair the power lines fail. The clock is ticking. Finally, they find the ruptured slurry pipe. The flood of slurry in the tunnel will have to be pumped out and a skilled pipe fitting team brought in to do the repairs.
We're pumping it out now. When we get the level of the bentonite down, then we can take out the pipe and put the new pipe in.
But there's limited light, power, and access. It takes the teams 3 days to fix the leak and clean up the mess. The slurry system is finally back on track, but there's still a risk for more trouble ahead.
Everything is overused and abused to such an extent by now that anything can break down. And if anything breaks down, we won't make it. People are a bit nervous, including myself.
April 2nd, 2007. Malaysian officials gather at the final breakthrough point, waiting for the TBM's arrival. After almost 3 years of tunneling, the 4-story high drill breaks through. A wave of pressurized slurry announces its arrival. They finally made it. The $25 million TBM will soon be dismantled piece by piece and shipped back to Europe for its next assignment. For Senior Project Manager Gus Klados, it's been a rough but successful ride.
To complete a 9-kilometer long tunnel, this large diameter tunnel in a city this close to the surface in more than difficult geological conditions, it's something, so it's good to be over.
The workers Gus trained for the job are now experienced tunnelers. They've even broken a world speed record for their type of TBM, building 17 rings in a single day. It's a day they'll never forget.
It's a very special feeling, beyond words. I think everybody feels the same after a few years of hard work. Finally, we break through, and of course, there are more work coming. But it's a day that we should celebrate now. Yes.
Congratulations, guys. Very, very well done. Thank you.
The SMART now reaches nearly 10 kilometers from the Klang River in the north to the Karayong in the south. But just weeks after the breakthrough, a huge tropical storm lashes Malaysia. As water rises in the Klang and Gombak rivers, another flood in downtown Kuala Lumpur seems imminent. The tunnel has been built, but will it actually work? What will happen when the tunnel's roadways are flooded with millions of liters of raging water? A huge tropical storm pounds Malaysia. Floodwaters threaten to cripple the city of Kuala Lumpur. Officials prepare to put their giant new SMART tunnel into action to divert water from the Klang River in the north to the Karayong River in the south. They still don't know yet if it will actually work. The SMART tunnel was designed to handle 3 different modes. Mode 1 is for normal weather. In this mode, both levels of roadway are open for traffic, and the water channel below is closed and dry. When moderate storms hit Kuala Lumpur, the tunnel will enter Mode 2. The roadways will still remain open. Now, floodwater can flow underneath the traffic. The most critical mode of all is Mode 3. If a giant flood surge is threatening the city, the tunnel roadways will be evacuated and the raging river water can surge down all 3 levels of the SMART. That is, if everything goes to plan. The storm continues to drench Kuala Lumpur. As river levels rise, officials divert water from the Klang River into a holding pond before channeling it in